Excuse me. Hello, Flat Earth researchers, debaters and debunkers. How's it going? Still the weekend for some of you? It's Monday evening here in Phuket. Just pour myself some tea while I see if anyone comes in. And we're going to have a look at a response video. We're going to make a response to a response video. Hello, one man. Good to see you again. Have you been at work today? Lightning 300. Hello. Thank you for your comments as well on the previous video. Appreciate that. Yeah, Will Duffy has popped by into the comment section in the previous video. So we've been having a conversation there. But this is kind of related because I'm going to talk about, well, as I said, it's a response video to a response that was put out for a video I did recently about a suggestion to measure curvature. And this has obviously been something that's been put out there for a long time, but it was suggested as something they could do when they're flying to Antarctica. Jess Palmer, hello, long time been working. All right, good man. Oh, you quit your job last week, one man. Oh, sweet. Okay, was that just on a whim, or was it a long time coming, or what? Do tell. Yeah, you're free. Oh, brilliant. Yeah, well, we'll see what you have to say about that. Yeah. But this is great. What we're seeing is I mean, various people have put out ideas of measuring curvature. Often it involves observations, and that's cool to an extent, but of course we know that what we see is distorted in a way, isn't it, really? And so, the fundamental thing that we have to realize here is that when people are arguing about the globe, they're arguing about a globe model and a whole bunch of imaginary things that go with this. And this is this is always the case. And of course the truth seeker, or the flat earther, is focused on physical measurements, practical demonstrations, our reality. How does our reality measure? And of course we all know that the whole globe thing is a byproduct of the heliocentric model. That came first, and it wasn't, as we've said many times, no one ever measured curvature. This is what you find out when you start looking into it. Okay, so how did they discover that the Earth was a globe? Well, that was never a discovery. It's never been measured. And in this video that we're going to look at, we'll see that Critical Think claims and admits that curvature can't be measured. So what you're left with is just this presupposition of a model. It's always a model. So whenever a globe earther is arguing with you about the globe, they're arguing, well, they say the globe model, but then it's the heliocentric model, with the sun being 93 million miles away and all that jazz, and gravity, of course, and how that's supposed to work. And of course, one of the myths that is perpetuated by these globers is that flat earthers don't understand physics, or the globe physics. It's not about not understanding physics. In fact, we demand the physics. We're asking for practical measurements, scientific measurements. And of course, this is the one thing you realize, that the globe and the heliocentric model isn't science. Explanations, even if they're called scientific explanations, are just based on a model, presuppositions. Yeah, and so there's of course this imaginary physics to go with it. Okay, let me just read the comments here. Jess Palmer, work is to keep you occupied from the truth. It certainly can be that way, can't it? But then you can find out a lot of truth by working, One man says, window cleaning 14 years. My boss was a narcissistic liar, couldn't take it anymore. Fair shout, man. Fair shout. Okay. Yeah, get it. The best you can't. You can never. There's no point in trying to win with a narcissist, is there? Um, you just have to let them out of your life. And if that means quitting your job, great. One door closes, another one opens. That's life, man. So I wish you the best of luck, man. Wow, cleaning windows is like that, like your average kind of town window cleaner, or are you hanging off tall buildings in the city and doing that kind of cleaning? I don't think I could handle that kind of job. Lightning 300 miles. I presume that means miles. My name says it all. See lightning bolts at 3. Ah, yes. Okay, yeah. Right, with my eyes and phone camera, I have video lapped lightning bolts at 300 miles plus. 1 miles of missing curve. Verified distance with radar app. Okay, nice one. Nice one. Okay. One man, your new job is a greenkeeper on a low. Oh, fantastic. Oh, man. Or yeah, although golf courses are very kind of man-made, it is a very chilled environment, isn't it? You know, that's brilliant. That's great, and you'll get to meet some get to meet some people, I'm sure, make some connections. That's fantastic. Nova R says curvature can definitely be measured. Well, you should take that up with Critical Think then, because he claims it can't be measured, and don't confuse making observations and calculations with measurements. This is another thing you have to understand when you're talking about a heliocentric or globe model. You're actually assuming distances to things like the sun or the size of the sun and things like that, what the Earth's doing. It's all assumptions, the spin, the curve, and none of this has ever been measured, not in any tangible way. Okay. And David H. Castro, curvature of your skull can be seen. That's true. Yeah, you can see it. You can look at yourself or other people. Yeah. One man. Okay, thanks, Nick. He lost a gold bar. All kind of jobs, both large and small. Okay. Huh. All right. Yeah, but that's it, man. You are free. And I was going to take a picture. I was at the market today. The market, and there's I love going there because you've got hundreds of people and they're all independent traders. Yeah, so you've got maybe a row of veg stands, and then you've got your fruit stands, you've got your seafood stands and your different meats and things like that. And you've got people actually making pre-prepared food. And I went and bought I get tobacco. This is 100 baht a bag. It's organic tobacco. I don't know how much it is. Maybe 100 grams or something like that, but it's 100 baht, yeah. So I get that, and so I'm not smoking any chemicals when I smoke. So I did give up smoking, but this stuff is really fine. Don't cough or anything after it. But yeah, you know what's wonderful about the markets, and so you have these big undercover places with all these independent traders. It's just usually family-run businesses or a couple or something, and they could be selling anything from, yeah, it could be fried chicken. Today I bought some kebabs. You know, and then had some fresh orange juice, freshly squeezed orange juice. You can get freshly squeezed sugar cane. You know, maybe someone's selling some papaya salad. It's just all these different stalls and stuff. So all these different people making a living, just doing their own thing. So they set up, and obviously it takes a while. The market might go on for, you know, 3 or 4 hours maybe. So they've got to set up and they've got to get there, and they might be cooking on site, or they're taking stuff they've already prepared. But then, you know, you'll find these markets half a mile or a mile apart. So you've always got people in the local community that can just sell their stuff. And for your average person, that's enough. They can make enough money for the day, and they might go once a week, twice a week, 3 times a week. It depends how often the market's on. But it's fantastic because that is the old way of living, and that was. It's great because you interact with people, you get to try different stuff. People get inventive with what they're selling. Yeah, it's just real life. Yeah, that's what's so good about it. Yeah. Nova R says calling all measurements fake doesn't make them go away. It accomplishes nothing, as we can't see here. No, I mean you're just, you know, that's just an attack on. It's true, right? What can you measure? You can't measure curvature. Yeah. Yeah, the markets have been there for thousands of years. Yeah, it's only in the last generation or so that these things have disappeared, just because you've had, you know, the all-powerful supermarkets come along, and you've got this kind of, yeah, I mean, the 9 to 5 mentality, pop to the supermarket, get everything in one go. It's all rush, rush, rush. And then, you know, now you're dealing with these robotic checkouts. You know, it's devoid of any real life. It was only maybe back, you know, 20, 30 years ago, maybe 40, that you could go to your local town. There'd be different small supermarkets, the butchers, the greengrocers, this guy Oxfam or whatever, you know, shoe shop, pubs. Yeah, it's all changed now, hasn't it? You know, all these people doing their own thing. It's all for this globalistic approach, and that's mainly what the globe is. It really is a commercial thing. It's a commercial model. It is a model. It's a model of time. It's a model. It's just imaginary. Yeah. It's all just a model. So again, you know, back to the point. People are always talking about a model. Yeah. When flat earthers are talking about, let's measure reality. Okay, if you want to look at the sun, do that. But what can you gain from looking at the sun? What can you actually prove? You could make a model, and this is something I've been arguing about with. You know, you could make a model with concave, convex, globe, if you like, or flat, and you can put the sun somewhere, and you can model it on the angles that we see the sun to. It all works out the same. The shape of the earth doesn't make any difference. You have to assume certain things are going on beneath your feet, or or places you can't see, outside of your reference frame, or millions and millions of miles away. These are all just part of this model that's been cobbled together. So you might well, so again, Nova, the difference is between calculations and measurements. Anyone can create a model. You can draw a circle, and you can draw angles, and you can assume sizes and things like that, and you can point towards the center of a circle, and you can say that way's down, and that's your model. But that doesn't prove what reality is. So that gets us onto this. Yeah. Okay, so what's that? Kleb Ruckus 2 gonna need a flat plane for those angles to the sun. Absolutely, yeah, yeah. And even so, even if you assume that it's on a globe, well, you're obviously starting with horizontals, aren't you? You're going level. You're starting with a horizontal on that globe, wherever you are on the globe. So it's always an angle up from horizontal anyway, isn't it? Yeah. So nothing changes. People, I nearly bought today one of those bendy rulers. 30-centimeter ruler that's all bendy. You can bend it all whichever you want. The length of the ruler, no matter how bent or straight it is always 30 centimeters. Doesn't change the distance that you can go across the surface of the ruler, whether it's bent, curved, straight, whatever, does it? Yeah. So let's get into this and refute it. Oh, I may as well introduce it now because it's there. So here's an inclinometer. All right. So this video was suggesting, the video that I made originally was suggesting using an inclinometer. This was a suggestion made by a friend Leon, who said surely there must be a way to measure any change when you're going around a globe Earth. Okay. So you can see here that this is a nice one. It's for cars. It's a free one I got from Google Play. So you can see that if you tilt it, it tells you that you're tilting. And of course, if you do it like that as well, you can show that it knows where level is. But you can also, if I just click this, okay, you can now establish. Oops, hang on, let me do it again. Right, I think I've set that as level now. So when I come true level, it actually shows a difference. Yeah. So then I can go back to that. All right. So. Let's hear the argument anyway, and he offers a demonstration as well. All right. Nova true. I'll just read this answer from Nova. That's true. The ground you stand on ought to do it. No need to extend the line out even 10 meters. All right. So I'm going to try playing this, and then we'll stop at some opportune moments and do our own little response here. And chime in, of course, if you want to. So give me a second. Let's just make sure this works. And you could easily take this on a plane with you to see if there is a difference in the angle from the start point.
You don't understand the globe model. Before you can propose an experiment, you need to understand the physics involved. You don't understand the globe model. Now,
all right, now hands up if you don't understand the globe model. Is anyone out there? Hands up, come on, don't be shy. You can tell us if you don't understand the globe model. Anyone? Anyone? Let's see. Or does anyone want to have a go at showing that one of you, who's a flat earther, a stupid flat earther, can actually offer an explanation, a very brief explanation of what the globe model is? Okay, Jesse understands that it's BS. Okay, we'll stick with that answer. Okay, it's BS, sir. Could you explain a little bit more? We don't understand. Okay. Oh, it's bollocks as well. It's BS and bollocks. Okay, teacher, sorry about that. The students are being rude. Okay. Alrighty. Okay, let's see what he says.
I'll be back in Thailand again a little bit later in the year. Quite happy to come, visit, give you a few lessons on the globe, point out where you got it wrong. Right? No problem with that. Just hit me up. I'll try and make an effort to get to Phuket and show you how the globe works. But right now, let's just have a quick look at a globe and show you why this is a ridiculous and false experiment. So we've got our globe, right? Now, you should know that the direction of down on a globe is always the direction towards the centre. So if I'm here, that's the direction of down. And that's your inclinometer only knows the direction of down. It does not have any internal gyroscope or anything that fixes it in space. No, it's...
All right. Okay. Are we getting it so far? Are you following? I know it's really difficult, but are you following? Yeah. Let's see. Okay, a globe requires a downward vector. Okay, very good. Very good renewed awareness. Cold star, a downward vector. Okay. Right, Celeb Ruckus. When rising above any sized sphere, the ground will drop away in all directions. This is what we see in reality. No? Okay, well, you know, that's that. We're talking about observations there. Let's stick to kind of making tangible physical measurements, yeah? Okay. All right. So, okay, let's carry on. Okay, we're still very confused, but, you know, you can obviously see that what he's saying here is that down is towards the center of the globe. Okay, so this, again, this is a model. This is a model. This is not necessarily what reality is. He's just explaining the globe model. Okay, so we do understand now that if we draw a circle, then down is anywhere around that circle that's towards the center of the earth, right? Okay, cool. Okay, man, been doing this for 10 years and I only just realized, oh my goodness, how foolish of me. Okay.
It's not that, it's just knows where the gravity vector is pointing.
Okay, so the inclinometer, he says, knows where the gravity vector is pointing. Well, it knows where down is. Okay. Does it know that it's pointing towards the center of a spherical Earth? Does this know the difference between just down, just straight down, and the floor being level beneath it, or it being somewhere around a globe and that surface being curved? Does it know the difference, or does it, it's just knowing down? All right.
So if you move to a different location, right, you'll notice, can you notice that this is still pointing to the direction of down, but it's actually a different direction?
Okay, so it's it's pointing in the direction of down, but it's pointing in a different direction. Okay. It's starting to get a little bit confusing here, man. I don't know if I can cope with this. This is creating some cognitive dissonance, yeah? it's still down, but it's going in a different direction. Down has changed. Okay. All right. Okay. Let's go. I'm really, I think I'm getting it. This is
Now,
great.
you're thinking in your mind that the inclinometer will show a different reading when it comes over here. But no, it cannot, because it's still pointing down. So if we were to, I'll get my phone here, and my phone
This is great.
is
fantastic.
like an aeroplane. I'm flying over the earth there, and you've got the direction of down. Your inclinometer is pointing to the direction of down, which will be roughly perpendicular to the aeroplane. Now the plane flies around the curve. Now you can see on the globe the aeroplane is still level, because wherever you are on the globe, level is perpendicular to down.
Okay. There you go. So level isn't this anymore. Level is perpendicular to down. Okay. All right. So level's not level. It's perpendicular to down. So this isn't level anymore. It's perpendicular to down. All right. Well, let's try that, because it's funny, isn't it? So that he does a demonstration, not in reality, but with a model. Okay. So he's demonstrating that in the model, the globe Earth model, when this thing goes around a sphere, then it knows where down is. Okay, so it knows that horizontal is perpendicular to down, so you shouldn't see a change. Okay, so I've got this very spherical lamp thing here. Okay, it's a glass thing, so let's do it. This is brilliant. Yeah, so I've got my inclinometer on here. Okay, so I'm going to do the same thing. Now, if I do it the same way as him, you're not going to see what's happening, but we can get it. It still kind of knows where down is, right? And so voila. Oh, what's happening? Okay, all right, yeah. So even when you try and do it with a model, then it doesn't work. It doesn't know, this inclinometer doesn't know that we are now assuming that down is towards the center of this sphere. It's still just registering down. Okay, and as I said, the fantastic thing is that you can do this. Oh, look, I can now make it level. Now it thinks it's level. I put it here, and I put it back up here. Oh, it's not level anymore. All right. Wow. Yeah. So I changed its down direction. I told it that down was this way, and it accepts that. It's like, okay, cool. You've got down towards the center of a spherical lamp. Great. Okay. Now we'll carry on going around. Oh, damn. Oh man, it looks like we were somehow able to measure it. Yeah. So of course, it's well understood that we're talking about the Earth. Oops, let's just try and get this back. The Earth itself being level, so or curved, and so we go along the Earth. So this isn't going to change. This isn't going to change if I keep it level, horizontal, is it? Or is it? If it knows it's going towards the center of a spherical Earth, then if I kept this level and I went and I held this level for 5 miles, 10 miles, a mile even, then what would happen? Then if gravity, if this downward vector from the spherical Earth beneath us is pulling it, then actually we're going to see this pull, aren't we? We're going to see this pull in this direction towards the globe. I don't get it. Oh, what am I not getting, Nova? Yeah, what am I not getting? All right, let's just let's just carry on. Okay, so in his demonstration, if we follow this demonstration, we're going to see a change in the angle. Yeah. So can we do it? Can we actually recreate? Can we recreate this in reality? Can we actually go around a curve on the surface of the Earth and see it not change? So, okay, if it doesn't change when we go around a curve, then does it not change when we go horizontally either? So what's the point in having a inclinometer if it can't tell the difference between horizontal and curved? It seems to be able to do it.
And also the inclinometer is still pointing down. So...
Well, yeah, I mean, he's saying that it's still pointing down. But I bet if you looked at his inclinometer while doing that, it wouldn't be pointing down, would it?
No matter where you fly on the globe Earth, even if you believe that the Earth is a globe or not, you've got to get your experiment to fit the model.
Right. Okay. Very good point. You've got to get your experiment to fit the model. Not reality, fit the model. So the model says that level is curved, but level is level. Or horizontal is level and curved is level. That's the model. But if you actually try and apply the model, which has this gravity, this downward vector going around a curve, then horizontal should be a measurable difference between... Yeah? Either way you look at it, there's obviously only imagination at play. You're literally focusing on a model. Yeah? Yeah? So I get it, Nova. We all get it. We've all gotten it since we were in school and we were told this. We can all imagine it, yeah? But how has anyone ever proven this in reality? So someone says you're going around a curve and you're flying around a curve, but it's registering as level. It's not registering, it's not measuring any curvature. Well, where did any measurement of curvature come from in the first place? How did they establish that? Sticks and shadows, looking at the sun? Nova says it's not even a debate. Well, it is a debate if you cannot measure curvature and you can only imagine it. Then we're debating about models, a model versus reality. In reality, we cannot measure curvature. Horizontal doesn't measure curvature. Yeah, the horizontal doesn't change, and when you go around a curve, it changes. That's reality. So we're debating reality versus a model. What are we believing in? You've got someone who's believing that you cannot measure curvature. And the only way he can demonstrate that is with a plastic ball. Can't demonstrate it in the real world. That's right, one man. A man-made model taken from his mind and not reality. Yeah. So yeah, it is interesting, Nova, because it does get you thinking. And actually, hopefully, what this does is you think to yourself, right, how can I prove these stupid flat earthers wrong? Surely there must be something. Surely someone somewhere measured curvature and didn't just assume it. Surely in the real world we can find a way to measure curvature. There must be a way. Shall we carry on?
Right. So the inclinometer will not change its reading.
Okay, so you're going around a curve and he's saying that if you go around a curve, the inclinometer will not change its reading. It will remain level. So what would happen if you kept it level? Would something change? Yeah? Or is there no difference, no measurable difference between horizontal level and curved level? Yeah? Nova R, if you put a strong magnet in the center of a globe and put a metal guy on the surface, that metal guy would be pulled to the center no matter where he was on the globe. Yeah? So, is that what's happening to us? Prove it. Prove your analogy. That's an analogy. That's an imaginary scenario. Yes, you can recreate that with a magnet. Well, can you do that with gravity? Can you recreate gravity? Gravity isn't like a magnet. No, it's not complicated. It's not complicated, Nova R. You have to get past this. It's not complicated at all. It's very, very simple. But is it demonstrable? It's not even demonstrable on the plastic globe he's got there. And it's not demonstrable in reality, is it? Yeah?
It will be always be pointing down, so you cannot get a change in reading. You cannot measure curve with.
There you go. All right. So we have the omission. You cannot measure curve. That's fine. Okay. You cannot measure curve. All right. So you don't have anything based in reality to assume that you're on a ball. Nothing but a model in your mind. Yeah. Plastic balls, just like kindergarten. Yeah. Or imagining magnets. Yeah. Hello, Flat Earth Warriors. Yeah, we observe gravity where? Oh, I dropped something. The Earth must be a ball because I can drop something. Oh dear. The Jolly Man, it's a model for decorative purposes and not for educational uses. This lunatic is imagining he's in fake space above it. Yes, have a look at the bottom of your globe. It will tell you. There's a little sticker on it. Nova R says the model is based in reality. Where is the measure? Where is the curve? It doesn't exist. There's no measure of curvature. In reality, we measure the Earth as being level and horizontal. That's reality. Oh, you know. Yep. So Nova R, same thing. Flat Earth has no model and never will. Well, so what? So what? Nobody's claiming to know. That's fine. This is the thing. You and your compatriots have a model that you believe in, not because it was ever measured or proven in reality. It's just a model, one of many possible models. And you know, like the sun is 93 million miles away and 400 times bigger because it has to be. Just like the globe has to be done in Photoshop. Yeah, because it has to be. Yeah, the Earth has to be a globe because it's in a heliocentric model. Like I said right at the beginning, the globe is a byproduct of the heliocentric model because it has to be. You can't have a flat Earth in a heliocentric model. So when someone decided that we're going to put the sun at the center, just because it would be a better way to avoid talking about creation, we'll put the sun at the center, and then okay, if the sun's at the center, the Earth can't be flat. It has to be a spinning globe to get day and night. Yeah. All right. So if you can tell me, Nova R, where all these measurements, what are you basing everything on? This is it. This is what the Flat Earther or the Truth Seeker questions. What are you basing your assumptions on? What are you basing your model on? It's not on measured reality. It's not on any measurements. It's all based on assuming what down is, gravity. Yeah. Or assuming that the sun is this far away or that big. Yeah. There's no measurement. No measurements ever started it off. Yeah. All right, let's carry on. It won't be much longer. There's a couple of comments below that I'd like to look at as well.
This experiment. So
that's just a reminder that he mentioned that there's no gyros. So no gyros fixed in space. I won't rewind it, but he did say that earlier on. So he's saying that in an inclinometer, there's no gyros fixed in space. Okay, so one of the other suggestions in that video, and of course has been suggested by many other people, is to actually use a gyro. Let's take a gyro on an aircraft or something, or across land, however you want to do it. And given that gyros have rigidity in space, once you spin them up, even the physicist Dr. Llewellyn has demonstrated this, yeah? And you can do this and that, and yes, you could take a gyro around the globe, and it's not going to follow the globe, it's not going to follow your model, it's just going to have rigidity in space. So it seems that Critical Think here would candidly admit that if you had a gyro fixed in space, that would be a way that you could show that, well, you're supposed to be going around curvature, but this gyro remained fixed. So there would be a difference then in your level if you went some distance along the Earth. But does that ever happen in reality? Yeah, so we'll come to a question about that in a second, about the whole gyro thing.
Forget it.
By the end of the journey, you should have a bias that would show you measurable curvature that is equal to the number of degrees compared to the distance that we've actually traveled.
So just to kind of update on that experiment, the idea of that experiment was obviously, when you'd use an inclinometer And when you're doing flight plans, for example, or you're talking about the globe, you're talking about degrees, right? So, when they talk about a change in degrees, and of course it's going to be, it's going to be your 45, your 90, your 360, whatever. Yeah, these degrees, no matter what distance you're covering, you're supposed to be changing degrees. So mathematically, you can calculate that. You can say that 60 nautical miles is 1 degree. So, the more nautical miles you do, the more degrees you will have gone around your globe. Okay, so yeah, you can calculate that based on this assumption, the R value or whatever. Yeah, and with nautical miles that were constructed to be easily converted into degrees. Or you could use a Haversine formula. Yeah, but this is all calculations. That's not measurements. Yeah, so he started off this saying, kind of making fun about, you converting miles into degrees. So he looked at a signpost and said, "Oh, that's so many miles. How many degrees is that I've got to go?" But that's of course what they're talking about. They're talking about terms of degrees when you go around the Earth. Yeah, let's just carry on.
Well, no, that's completely false. And I've already explained that. I skipped over the bit about what the experiment's all about. But so the inclinometer will measure your level. So it knows the direction of down. Not going to work. It doesn't keep track of an angle.
So an inclinometer doesn't keep track of an angle. It knows down, but it's not going to work. Just rub in it. If you're a builder and you've invested all your money in spirit levels, forget it. Doesn't work. So one man, if you're going to apply for a carpenter's job or something like that, or an engineer, don't, because it won't work for you because you don't believe in the globe. So whatever you do on the job, it's not going to work. Your plums are going to be out of whack and everything. You're not going to be able to get any right angles because you're not a glober. It won't work for you. Your belief will affect your work, man. Don't do it. You'll get into trouble.
It only knows one thing, the direction of down.
Right. The clinometer only knows one thing, the direction of down. Okay. So, which way is down? You might assume one thing. So if you're assuming that down is around the spherical Earth, then horizontal is what? Does horizontal end up being that? Is that horizontal? If you carry on going horizontal, do you end up getting that? Because that's what you're saying. If it only knows down around a globe, yeah. Let's get back to the chats a second. Well, it doesn't work perfectly fine, does it, Nova R? David Banner, hello. It is great. It's like, get back to school. The Jolly Man. No inversion over any axis. Missing relative inversion on the fake globe Earth will invert. Okay. Okay. That's too sciencey for me. David H. Castro, a conditioned mind is hard to break. Good luck. Yeah, it is, isn't it? It is. That's the thing. We all know. We all realise that we got conditioned. Lightning. With your phone, find a cloud layer app. Okay, cloud layer app. During the day, I have matched cloud patterns at 200 to 300 miles with MU app. I make a gamer. Oh, cool. Okay, good idea. So yeah, you're seeing clouds, or you're looking. Is it like you're seeing or know that from the app that there's clouds that are a few hundred miles away, but you can actually see them. So that's great. There you go. That's a great proof. Okay. Gabruckus, up and down in a reference to a horizontal plane. Yeah. All right then. Okay, so it's just a little bit longer, and then there's a little comment from Wolfie down the bottom there.
And whether you like it or not, on a globe, the direction of down is towards the centre.
Hey, again, it's not about whether you like it or not. It's fine. Okay, on a globe, that's your model. On a globe model. This is it. You notice how it's not saying on the Earth. In reality, on a globe model, down is towards the centre of the spherical Earth. Okay, fine. All right. So how are you going to prove that that is what reality is when reality doesn't demonstrate that in any way whatsoever? In reality, it's level. We can see further. We can see clouds 200 miles away. Yeah? Or lightning. Yeah. Yeah. Right. Anyway, I think, yeah, blah. So there was let's just go down to a comment. I think, yeah, Wolfie put one here. There's a comment by Wolfie. Let's just check that you can see that. Oh, maybe I need to expand. Just give me a second. I'll expand that so you can see it. Oop. Okay. Bring this in. Okay, sorry. Right. What's Wolfie saying there? Wolfie says, it really is bonkers to think an inclinometer on a plane will detect curvature. They operate by sensing the direction of down. This guy is repeating the same thing. The direction of down changes as you move around the globe. Okay. Yeah, does it? So how are you going to prove that? What measurable proof have you got that? The globe model, all right. But even when you use a model, it doesn't work in reality. Yeah. On this changing direction of down. So down changes direction, but it can't be measured. But down, when down doesn't change direction, that can't be measured either. Yeah. So yeah, this has been explained to Phuket Word many times, but he still doesn't get it. Again, the explanation is understood. Very easy to understand, the explanation, but we're talking about science. You're talking about a model that you think is based on science. It's not, it's based on consensus that's been manufactured. Yeah. So there's no scientific measurement. They're claiming that you don't know physics. Well, yeah. Well, where is the real world physics that demonstrates what you're claiming? Yeah. So it's not about you having to explain it and not getting it. You cannot demonstrate it. Yeah. I could explain any way. You can explain anything. You could explain that it's concave, it's whizzing around, it's this, it's that. You can make up any explanation you want. Anyone can make up a model and justify it with explanations. Say, oh, it's not like this, it's actually like that. But this doesn't happen, but this does. And then he's got another one, another comment. Wolfie says, Phuket Word blocked me long ago on his channel and again recently on Twitter. I honestly don't know if I did. I let him go for a long time, but it was never constructive criticism that I got from him. So, yeah, he can't answer my simple questions, so takes the coward's exit. Again, the simple question is, where's the measure of curvature? And as we've always said, all you'll ever get is excuses. So Wolfie 6020 is someone who has the equipment. If he's a pilot, he's got the inclinometers and the gyros, and he's got this and he's got that. He's got drones. He knows how to open up the equipment. But somehow, he's in league with Critical Think here, and neither of them can actually measure curvature. Critical Think says you can't measure curvature. Wolfie obviously agrees with him. Can't be measured. Can't ever be measured. It can only be assumed. Yeah. All right. Yeah. Oh, let's bring that. So, yeah, there you go. Just a second. Let me open this up again. And bring that back. All right. Okay. I won't play any more of it. I think you get it. Yeah. So this is it. I mean, I keep asking the Globers. Keep asking. I said with conversations with Will Duffy, trying to actually help them come up with an idea for measuring curvature. They don't want to hear it because all they're talking about is a model. They're assuming everything based on a model. So they're arguing for a model, a belief, not reality. Yeah. And of course their only defense is to say, oh, you're stupid, you don't get it, when of course we do. Okay. And we can all repeat it. Yeah. Okay. So here's my globe. All right. Here's the globe. And okay, down is towards the center of the globe. Okay. Perfect. Fine. Okay. So how does the inclinometer know? How does it know that based on your belief? What changes? Yeah. So, oh yeah, I think, no, what was it? Wolfie said something about, hang on, let's just go back down there, because he said something about gyroscopes. That's strange. I thought I saw him say something about gyroscopes. move around the globe. Aircraft. Okay, yes. Aircraft artificial horizons are pendulous vanes. Use pendulous vanes to consistently align the gyro based on this changing direction of down. Without the correction, the instrument will be useless. Okay, that's a common myth as well that you'll hear perpetuated by these anti-flat earthers and globe earth believers. No, it's maybe you didn't see that because it's okay, sorry. I'll widen the screen again, shorten it here. Sorry about this. Okay, let me just show you the comment. All right. So yeah. Now the pendulous vanes really, okay, you've got gyros that are fixed in space, and yes, they will precess. That's just a natural thing that gyros will occasionally do, right? But it's not because the Earth is turning beneath them. It's not related to that. It's just something that gyros do, yeah? The same can be said for something like a pendulum. They don't go in a straight line. That's why pendulums on clocks have to have a fixed, a hard, solid thing holding them. They're not on loose things, yeah, because they would just kind of swing about, yeah. But it's not to do with the Earth doing anything beneath them. But the pendulum. So when you have a gyroscope that's being powered by a vacuum pump, then of course you have to have an outlet. It just otherwise the air doesn't go anywhere. It's got to flow. Yeah, and of course a gyro will get knocked about. If you fly about and you're doing things pretty smoothly, your gyro will maintain its rigidity in space. But obviously, if you do knock it in certain ways, then it will change its angle or whatever because the torque that is applied, the 90-degree torque, right? So yeah, if you're flying about in an aircraft and stuff like that, it is going to get jigged about, right? But essentially, yeah, so all that's ever happening with a gyroscope is it's being kept level. It's being kept in its original orientation. And that's how, a basic flight instrument, whatever it's called, flight thing will work, right? It needs to know where level was to start with. And a lot of the time, GPS is not because they're getting signals from somewhere. It's just this whole electronic system keeping track of the speed and the direction since it left its original place. It's all being stored. It's all just kind of going off the original level, okay? But again, if you want to say that a gyro, on one hand you've got the real physics of gyros, which is to have their rigidity in space, yet you're claiming that a gyro will follow a curved Earth. Can you prove it? Can you prove it? Can you show the difference between horizontal and curved? No, you can't. If you try it, then there is a difference. Horizontal remains horizontal. Curved changes that axis relative to the curve. Yeah. So you can't demonstrate it. And could you perhaps demonstrate this while you're flying? No way. No way. You would have done if you could have done, but instead you're just making excuses and assumptions that level is curved because you decided where down is. Let's have a look. Who we got in here? Nova, send up a rocket. Then what? What's going to happen? Yeah, look at rockets. What do? Does the Earth rotate beneath a rocket? They sent up a rocket for the Amazon thing, shaped like a dildo. Yeah. What did it do? It just came back down. The Red Bull jump as well. Didn't drift as far as it should have done. The Earth doesn't spin underneath anything. And it's impossible to be carried along with the spin. That's ridiculous because you've got winds changing in all directions, going all over the place, just like water flowing. Yeah. So there's no atmosphere sticking to the Earth that's going around with you. Doesn't work. Doesn't work whichever way you try and explain it. Yeah. Yeah, Nova, you can prove flat Earth easily because you just measure it level. The Earth is measured level. Everything is done level. It's proven every day by everyday people, even pilots. Flat Earth Warriors says Professor Lewin proved Earth flat with his gyroscope. Yes, I love that experiment. I'll try and bring it up sometime. Yeah. Nova crowdfunder rocket. Talk to Kip Douglas. He has some experience. Well, this is it. All you guys have these wild ideas about spending bucket loads of money to go and look at the Earth from outer space. And no matter how high anyone goes, You still don't see a curve. Yeah. Yeah. Why don't you just crowdfund a 10-kilometer measurement? This is what this original video was about. A 10-kilometer measurement across across the Earth. Yeah. And measure the curve. Find a way to measure it. Show that difference between horizontal and curved. Measure it. After 500 years of scientific exploration and explanations, you still don't have a measure of curvature. Yeah. Jess Palmer, what the globes don't understand is the burden comes down to the person claiming something to be, we are absolutely spot on 100%. Their claim is that horizontal changes to curved. Great, prove it. If you can prove it and measure it, fine. And then we can repeat it all over the Earth and we can see that I'm upside down when I'm going to Australia or something. Brilliant, okay, happy with that. Still got lots more questions after that, yeah. I addressed this in the last video about people. They say that flat earthers are afraid to be wrong. No, not at all. We're the ones giving you all the experiments, thinking of these experiments and saying, hey, do this, do that. All you guys can think of is go up in a rocket, send you to space, put them up on the space station, and they'll still come down and up. Yeah. This is what flat earth does to you. It brings you back down to earth. Yeah? Gets your head out of the bloody clouds. No, not clinging to the flat earth and just, we're all looking at demonstrable reality. Reality tells us it's level. It's the globe earthers saying, you must believe in my model, that are making all these claims but can't back up their claims. Yeah. Therefore, the globes need to prove. Jess Palmer says, therefore, the globies need to prove to us these things, not us. Exactly. Yeah. That launch and grab was ridiculous. Yeah. Again. Yeah. Whatever. I mean, whatever Musk is doing. In some ways, he seems like a good guy, doesn't he? He certainly. I saw a clip the other day where he said he doesn't like Bill Gates, because Bill Gates is and actually Elon Musk is saying, well, look, we can fit a lot more people on this earth. Let's have more babies. Let's have more people. So he's like, yeah, he's all about abundance in some ways. It's difficult to know, isn't it? I mean, yeah, you can say he's a controlled opposition and blah blah blah, and Twitter has become kind of quite politicized these days. So whatever, take it with a pinch of salt. But yeah, I mean, I wouldn't deny necessarily that the technology is now there, to do that, to send a rocket up and send it back down. Again, you're just banking on this fallacy that watching rockets go up means that we live on a globe. We still send a rocket up from a flat Earth, and it'll still come back down again. Yeah. So I don't waste too much time kind of trying to scrutinize that. I mean, obviously in the early days, you look at the NASA footage and you see that they're doing things on wires. So, well, why do they have to fake it? Well, because they're not really doing it. Simply. Yeah. Okay. But we're not. Even if they're sending satellites up, I think there's still, if whatever's going on up there, whether it's some kind of soupy kind of whatever, it doesn't have to be a firmament. It can be some kind of gaseous, liquidy thing. However it all works. So there might be a point where if you send something up that's light enough, it will just travel around. We know there are winds going around. I mean, again, even if you believe in a globe, there's still assumed to be winds that are going hundreds of miles an hour. Yeah, even if you fly. I remember flying once and coming back, and it was an A380, one of those big ones. You really can't tell what's going on. But the pilot, when we got down, the pilot said, "Oh, thank goodness for that. We were battling 400-mile-an-hour winds." And it's like, whoa, yeah. So, yeah, it's nothing to do with Coriolis or the Earth spinning. These things are going on up there. Yeah, there's this whole whirlpool going on. So I imagine that just like, you know that you can put balloons up there and it will follow a path. Yeah. And if the sun and the moon and everything has anything to do with it, it's all doing circles, maybe. or ellipses or figures of 8, whatever it's doing, there's a path that it follows, yeah? Okay. The Jolly Man, apparently they can prove gyroscopes would not process, but don't fully understand how ridiculous the explanation is. Yeah. Tess Palmer, David Banner Spaces, as gay as it comes. Nova R. We do not need to do anything. We already know you're okay, so prove your claim. You've made a claim. You're claiming that there's a globe, but you can't measure it. You're claiming that we do not need to do anything. Why? What, we just have to believe you? Well, yeah, sorry. If you came to me and said, your wife's cheating on you, I'd say, well, prove it. Santana, 70, no, yes, it's level and lower is not curved, right, okay. Oops, sorry. Kleb Bruckus, deny flight mapping, navigation, building, tunneling, and all the horizontal plane of reference, and still claims sphere illogical to the end. Yeah. Again, Wolfie, one of his go-to argument is flight plans. Flight plans prove the globe. Well, again, it's just a calculation. It's not a measurement, and all you've done is convert a distance into degrees with a Haversine formula. Yeah? It's just theory. Yeah? It's not a measurement of curve. FPV, good to see you. Thanks for your pointers yesterday. Going to look into that. I know some people that are very interested in the stuff you're doing, FPV Angel, because what you're doing does make sense in a lot of ways for these people. Yeah. So, yeah. No, again, where is it? Rove, where are you? Nova, you're saying FE is a religion of sorts. No, it's not. It's completely the opposite. The globe, heliocentrism, is a religion. It's scientism. It's a cult. Yeah? And you look at it, you've got these priests, you've got the Neil deGrasse, you've got the, whatever it is, Cox, and all these people, or throughout the ages, yeah? The physicists, like what was that guy that loved to play with gyroscopes and things like that? He bashed heads with the conventional people all the time because he could see from playing with gyroscopes that the Earth isn't a globe, yeah? He never said it outright, but he says, look, you look at real physics, the physics of gyros, and it doesn't work, and entropy, the laws of entropy and all that stuff. Real physics doesn't fit with any of the globe theory, yeah? Nothing, yeah? So yeah, this is a realization we had, Nova. And it took a while. It took a few months, but I remember sitting there and realizing, oh my God, I was raised in a cult. Now it's easy to see from the outside, but when you're in a cult, you can't see it. But this is it. We're taught to look at the globe from school. This is before we've even experienced. We knew the critical thinking and know how to operate in the world. They're telling us that you live on a globe. And they've got, the space things, yeah? The mobiles and all the planets and stuff, and it's just repeated by the teachers, these people in authority, and they just repeat it, yeah? And you see it on TV, and you see alien movies, and, you see a UFO, and you think it must have come from millions of miles away, not just across the plane, yeah? So the globe is a religion, and the heliocentrism was started by the Catholic Church, or Catholic priests, yeah? Copernican model, that's what everyone's following. Yeah. But, you look back through history and you try to find where was a measure of curvature. Who did that? Oh, well, Eratosthenes apparently stuck some sticks in the ground and measured shadows. Yeah, and you can get the same results. And even if he did do that, all that's happened is the heliocentrists twisted and made a claim based on their interpretation of what it was. Just the same as, you drop something and that's assumed to be because you're on a globe, because gravity is from the center of a globe. Yeah? It's all just assumptions, yeah? There's nothing scientific about that at all. Yeah? So, flat earthers don't have a model because we understand that we don't know it all. We understand that we've been led to believe things and assumptions and presuppose a model that has no basis in reality. You can look up at the stars and you can study the stars, and yeah, you can see that, oh, right, okay, you've got these planets that appear to be going around the sun, and you've got even planets or moons going around Jupiter, for example, yeah? And then, but that's all going up in the sky, and then someone thought, well, okay, we'll put the Earth up there, in the solar system, and we'll put the sun at the center. Not because anyone found that out. It wasn't a discovery. A calculation at best. Yeah? And it doesn't change the angles at which we see things in the sky. It is what it is. The distances that we go from A to B is what it is. Excuse me. Excuse me. Too much ranting. All right. Yeah, exactly. Insane. Irby, or the globe model. Underneath, you'll see what it says. Good point, Lightning. How can a flood happen on a curved Earth? Yeah, and where the sea is supposed to be bulging out because of the rotation of the globe Earth, it's funny because along the equator there, where it should be bulging, you've got some of the shallowest seas, and these islands dotted around them. Yeah, that don't, they're there. Again, you've just got to interpret sea level as curved, not level. Right, what's that? Santa, sorry, the chat's really difficult to scroll through. Hang on. Santa, now Nova R says, who are you that we have to prove things to you? What are you doing going to do? Well, no, it's not about me. You don't have to do it for me. Do it for yourself. Do it for yourself. Do it for humanity. Yeah, this is why we all are out here saying, do your own research. Check it for yourself. Why do you believe that you live on a globe? Ask yourself. Where does that belief come from? Is it knowledge? What knowledge? Stories and explanations, but it's not knowledge from scientific measurements, is it? Because none have been done. It's all indirect measurements. Now, if you're going to do science, you want to measure something directly, because if you're measuring something indirectly, like you're saying, okay, I'm 70, 80 kilograms, because what? Why am I 70, 80 kilograms? I can make up all sorts of reasons why. I could say I'm on a flying wall, going around in circles, yeah, but I'm standing on the wall, yeah. Could say I'm rising up, yeah. Or whatever, I could say there's something pushing down, or something pulling down, or I could say the air pressure is on me, yeah. There's all sorts of ways, I could say that it's frequencies pushing me, yeah, in place. I could say it's density, yeah. Why does the density exist? Don't know, it just does. Why does the sun exist? Why does the earth exist? Don't know. These are big questions, and of course, scientism, the cult of scientism, would appear to have answers that don't give us any answers. You come from a big bang for no reason. Yeah, you evolved. Yeah. So it's not about I'm not demanding that you prove anything to me, but if you come with a claim, if you're coming here and saying you're stupid because you don't understand, well, okay, demonstrate it. Just demonstrate it. Yeah. Demonstrate why we're stupid. If it's that simple, if it's that easy to understand, demonstrate it. If it can't be demonstrated, then or measured, well, where's that coming from? It's coming from a belief. Is it not? Satanita, is that Satanta 70. Eratosthenes never validated the assumptions with practical verification of the curvature he was proclaiming. Yeah, and who knows whether he was proclaiming curvature? We have no idea. It's just a story. We have no idea whether Eratosthenes existed, even if he did, what he actually claimed or meant, and it's the same with all these people. Newton even. Newton, it's reported that he didn't actually agree with that. He just made up this stuff. He made up the model, his Newtonian physics. Some things are true, like, some of the laws of physics, but it doesn't tell us why or how maybe. Yes, it describes how things happen, but he didn't necessarily agree with it. He just made it up to fit with the model. Yeah. I mean, they needed that. They needed an explanation for the globe. It's like, well, how do we stick to a globe? How come it doesn't feel like we're on a globe? Oh, gravity. Yeah, what's that then? Explain it to me. No, demonstrate it to me like I'm a kid. Yeah. Why has it never demonstrated it when we're kids? Yeah. Usually in a science class, right, they demonstrate things. Okay, like you get a chemical, and okay, if you put this chemical in water, it's going to blow up. Watch this. Oh, right. Okay. Physics or chemistry. Yeah. Or if you do this, you throw this weight, it's going to do this. Great. Okay. And yeah, you find it funny that they point at a light in the sky as the answer. Yeah, this is exactly it. Yeah, and again, this is what the whole final experiment is about. You know, it's entirely based on this assumption of what the sun is, not what the Earth is, or the model, the heliocentric model. Now, again, I pointed this out in my first video addressing the whole thing. I said, when Will Duffy talks about the globe, or when any glober talks about the globe, they're talking about the globe model. And the globe model is the heliocentric model. And that includes a sun that's 93 million miles away. Okay, so you have to presuppose all of these things about the model. Yeah, not based on measurements. Nobody measured the sun 93 million miles. You know, as David Weiss points out, you know, how could you see something 93 million miles away? Impossible. Doesn't matter how big it is, how bright it is. 93 million. You're not gonna. And it's because I did a little drawing here, for example. Yeah, I was taking like, okay, the UK, and I went to timeanddate.com and I looked at the angle that that they are seeing the sun at the same time as Australia, looking at the sun, Perth, I think it was. Okay, so I put the angles on here. I used a protractor and everything. Yeah. Okay, so then I pointed these at the sun. Well, you know, how big's the sun? How far away is it? Well, that's all arbitrary. Do you know what arbitrary means, Reva? Yeah, it means you can make it up and say anything you want. Yeah, you can make up your model. And I was explaining to Will that, you know, you could, you know, concave, flat, you still have angles to the sun, and it, you know, what do you assume about the sun? Yeah, you've got to assume its size. Well, this is the thing. That's what I pointed out, especially with the cartwheel rotation that you'll see with sunspots. The sun and the moon do the same thing. All right. So in the heliocentric model, the sun is supposed to be so far away that it magically appears to be the same size as the moon, even though it's much bigger. Right. It's all assumptions. Yeah. So there's these observations that you can make of the sun, but it's 93 million miles away, and then you've got the moon, a quarter of a million miles away, a fraction of the distance. However, in the real world, in reality, the sun and the moon appear to behave in exactly the same way, depending on where you're located. So if you're north of the equator, some distance, you'll see the sun, if you can see sunspots, appear to cartwheel across the sky. And you'll also see the moon appear to cartwheel in the same way across the sky. So what's that telling us? They behave in the same way. Are their distances vastly different, or are they about the same? Because we're seeing them do exactly the same thing. And we're also seeing, you know, when you see a sunrise and sunset, it's coming up like that. Yeah? Yeah, it comes up in this big curve, it arches up into the sky, and we know that that's because of perspective. Something gets closer to you, then it appears higher from the horizon. That's just how perspective works. But they're telling you that it's because you're on a spinning globe and the sun's 93 million miles away. Well, if the sun was 93 million miles away and essentially static, and the Earth is moving, then there shouldn't be any kind of like whoop, whoop of the sun in our vision. It should just go straight across, no matter where we are looking at it from, because it's so far away. Yeah. So none of these assumptions for the globe Earth heliocentric model actually fit with what we see and experience in reality. Nothing whatsoever. Yeah. And you can assume, if you're just going to point at the sun and make your model from the sun, like I said, you can assume the Earth is any shape you like, and you can point at the sun, from a concave Earth, from a flat Earth, from a globe Earth, convex. You might make some adjustments to your model, your images. You know, of course, you can't model a sun that's 93 million miles away. Yeah, and again, in these orthographic video illustrations, actually, the sun is supposed to be many times larger. If it was an orthographic view where you don't account for perspective, but they always put the sun as a tiny thing. Yeah. So I think it's great. You know, this is it. It's all about, this isn't about demanding that you prove things to us. It's you should be demanding that you can prove things that you believe in yourself. If you can't, then where do you get your belief from? Question it. Stream peaked to 40 views. Okay, whatever, you know. No, it's been explained. FE's not a cult, the globe's the cult. Yeah, okay. Chilster Ducks, hello, Deluxe. They filled our heads full of shite when we were bands, so break free, some are stuck in a rut. Yeah, definitely. Prison Planet Earth, yeah. Alright. What's that? D? Hello D, and hello Graham. Cool. D, I wonder how Saudi Arabia is building the mirror line skyscraper on a globe. Oh, interesting. Yeah, that's a big project, isn't it? Yeah, immense. Yeah. That's funny, isn't it? You know, China and all these places, they're doing all these big projects, but the UK, I don't know if they're doing any big projects. Tom Servo says, he asks FP Angel, are you too cowardly to identify yourself so you can fight you? Oh dear. Tom Servo, why are you resorting to those kind of tactics? You've got people out there sharing their knowledge, wisdom, what they've learned. Why do you have to trash them? If you're going to trash someone, just prove them wrong with demonstrable physics. That's all you got to do, not with words and stupid stuff and ideas. Or my idea is better than your idea. Prove it. Yeah. That's probably true, Rune. Yeah. What's that, David? We probably got out hands in there somehow. Nick. Oh, I'm not sure what you mean by that. Okay, who wants some? Who wants it? Who wants it? Club Rockers. Tom's tough in the chat, but thick as mince. No science for your belief in the Catholic Church's model. Yeah. Okay. Yeah. So there you go. Chaps and chapesses. Yeah. Critical think kind of could basically only say that you can't measure curvature. So there you go. You heard it from a globie that you can't measure curvature. So you only have to assume it and believe it because that's the model. So this is all about belief. It's all about getting people to believe in stuff. Yeah. Hello, Pendle. Hello there. Big projects, David Banner. I mean, you know, they're like, I mean, whether it's the ports, factories, you know, infrastructure. You know, you can get in China. You can get about really fantastically easy now. Apparently, I'm not visited, but I've got friends there. Yeah, it's just like, you know, it's just yeah, and just but then, you know, the UK is kind of just doing weird things like filling fields with solar panels. Graham 9, think I'll go back to the globe. Form scary words, can't be worried. Tom Servo, flat Earth is growing exponentially. It is. Yeah. Okay. Yeah. D. The community is. That's right, D. Yeah. And what a wonderful bunch you all are, because we're all passionate, and that's fine. and we're seeking truth, and everyone's got their own thing and they've got something to share. You don't have to agree with everyone, and that's great, because on one side you've got a whole bunch of people that believe in a certain model and they don't know why. They have no idea why, because no one ever measured it. They haven't critically thought about where, you know, what are they basing things on? What are they basing their arguments on? And again, this is what, with the final experiment, their entire thing is the globe model versus a flat earth model per se, which is just something they kind of create, or, you know, dragged up for them, picked as a cherry. They cherry picked a map to say that's your model and this is our model, and we're going to have a contest about whose model is best. Not about reality, not about measuring reality. They're not going to do that. They're not going to try and measure curvature. Now, and this guy, Critical Think, says he's going to take some weights along and measure the difference in weight. And that, for him, is going to be proof that we're on a curved Earth. It's insane, isn't it? You know, I mean, even gravity could be different. If gravity was something to do with the density of the Earth, yeah, and, you know, if you have you know, maybe if you've got water underneath you, but then you've got a mountain underneath you, maybe there's something more that attracts you to a mountain or something, or just the Earth is denser and that could create more weight. But actually, you know, I did this with the gnome experiment. If you ever look through my vids a while ago, there's a gnome experiment. I spent weeks doing it because it was basically it was an experiment that was done by a scale making company, Precision Scales. It was a PR stunt. So what they were doing is they were sending their scales with a gnome. So you weigh the gnome. You had this gnome that would pre-weighed in wherever it was, somewhere in Scandinavia, I think. So they had it, and then they would send this gnome all the way on the scales around the world. So the same scales would go to these different places, and they actually went to Antarctica, and they went here and there, yeah. And so I looked at all these different places, and I looked at the weather, the air pressure at the time, the elevation, and all these other things related to where they'd sent these things. And so it wasn't consistent. Basically, the gnome did weigh fractions of a gram or up to a gram different in different locations, yeah. As far as Antarctica, they took it there, and then there was one time they took it down 2 miles down beneath. There's some laboratory underground, about 2 kilometers underground. They measured it there, yeah. And, you know, you look at all the information that's compiled, and you can still, there's a link. So if you go and visit that video, there's a link that shows all the data that I collected about the weather and all that stuff, based on the dates of the weighings of this gnome on these scales, yeah. So there were differences up to a gram in different locations, but it wasn't consistent with where that place was located on a so-called globe Earth. It wasn't necessarily lighter at the equator. In some instances it was heavier around the equator, even though if it's spinning and centrifugal force it's supposed to be lighter, yeah. So there's nothing consistent about measuring weights, and that doesn't prove, that's again an indirect measurement based on an assumption that you're spinning and you've got gravity and you've got these two forces pushing and pulling, or whatever they're doing, pulling apart, yeah. It's nonsense, yeah. So yeah, have a look for that. Just look for gnome experiment in my channel if you want to go and check it out. It's a bit laborious, but it was, I did a scientific evaluation of the whole thing. It's like these guys were doing a PR stunt, and they were just being kind of, you know, it was all fun and games, and it was based on this idea that you weigh things around the Earth being a globe, and it will weigh differently, lighter in some places and heavier in other places, but the measurements weren't consistent when it came down to it. Yeah, a good point, Chilster. Imagine being able to see 93 million miles. Yeah, and again, Rune Thompson, good point. Nova R, who is us? I can show you in person. You're in Denmark. Chilster Ducks. Yeah. Nova R, it's been mapped and it is a globe. No, maps don't show you the shape of the Earth, yeah? Alright. And that's true, Clabrock. The sun does not go behind a physical Earth curve. Yeah. All right, sweet. I think it's been good, yeah? It's been fun, yeah? So I hope you enjoyed your globe earth lesson there, all right? Remember now, children, down down is towards the center of a globe earth model. Down is towards the center, but you can't measure it. Can't be measured. Remember that. That's your lesson for the day, okay? Right, I want you to go away and do your homework. All right? I want it on my desk in the morning, without fail. No excuses that your pen ran out or the dog ate it, okay? So and otherwise you'll have to repeat after, you'll have to write 10 lines. Down on a globe earth model is towards the center of the spherical globe earth model. Yeah. Alrighty. Okay. Have fun. There'll be more of these flat Earth myths, Mythbusters. I enjoy them. It's great because you know it's all about the psychology. Yeah. We are talking about the difference between knowledge and belief. Yeah. And it's fun to do. Yeah. Detention. Yes. 6 are the best, David. All right. You'll take care now, okay? All right. Chok di. See you soon.